morning, third years. I hope you're all well. Right, we're going to look at working drawings this week. The one that you can see on screen just now is the exemplar from the class, the birdhouse that sits on the shelf. This isn't the one that you're all going to be doing. You'll be generating your own working drawing in this style to the birdhouse that you have designed as best you can. Now, there's a wee bit of theory behind this as well, though, that you need to know for your exam and also for your final assignment. So basically, during manufacturing, a technical drawing like this one is often required to find sizes, details of parts and the way that the product's joined together. And this, in its entirety, is called a working drawing. This usually includes an orthographic, which would be the elevation, end elevation and plan. Sometimes can include a three-dimensional view, sometimes to show assembly, sometimes not. A detail box on the drawing to give us information about the drawing. And occasionally, if you look at this manually completed working drawing, also a sequence of operations. We'll possibly talk about this next week. Now, to communicate the design in a working drawing, we use various things. So we use drawings and diagrams to show the essential information and details about the product. So this should communicate each part of the product. Here on this birdhouse, you can see the perch from the elevation. You can see it looking straight on in the end elevation. And you can gain an understanding of it from above as well, albeit it would be hidden from you from above. You'd be looking through the roof of the object. In addition to that, we have to conform to British standards for dimensioning, which is BS 8888. And that basically means on dimensions lines like this, we have to conform to leader lines, which do not touch the object. They're a couple of millimeters apart from it. And you'll find one of those at each side of the dimension. We have the dimension line itself, which must touch the leader lines and have short, sharp, filled-in arrowheads. The dimension itself, if it's horizontal, must appear above the dimension line and in the center, always in millimeters, so you don't need to put mm in. And if it's a vertical one to show height, like over here on the left, the number, the size for that dimension would be written to the left-hand side, but as though you were looking at the page from the right-hand side. That also should be above the line and centered over its distance. Down at the bottom left-hand side in the detail box, we have what's called the third angle projection symbol. Now this basically shows a cone with the top cut off of it, looking at it from the front and looking at it projected in an end elevation to the right-hand side. Now, this means that the drawing's been completed in such a way where the projection of those views can be understood from one country to the next, from one factory to the next, so everyone conforms to the same style of drawing. So that's the third angle projection symbol. The drawing also has to appear at an appropriate scale. This one has been drawn at 1:2, so that's half the physical size. We are possibly going to do our wooden birdhouse in the same scale. We'll see if we can fit it onto an A3 page. Don't panic too much about that just now, because again, this is orthographic sketching we're going to be doing. It's only a practice for now, and it does not need to be absolutely perfect. Now, in industry, working drawings are generally very detailed. Many drawings could be produced for the same product. Now, these drawings are given to all the production workers, and therefore they must be accurate so that we avoid any mistakes in manufacturing. Incorrect working drawings can ultimately cost the factory time and money. For the purposes of what we're doing, the working drawing needs to be accurate because you will be in the workshop at some stage, working from your own sizes on your own design. 20 of you will be building different products. two different sizes, and ultimately those sizes will reflect in your work. Okay, let's get a move on then. Right, let's get ourselves started. So, you're going to need a pencil today, something with a straight edge, in this instance a ruler, and a rubber. And ordinarily we would be drawing this on a drawing board, but as most of you won't have access at home, then I think we'll just do this as a sketch rather than a drawing. So the first thing that I want you to do to start with is across the bottom of the page, let's sketch in a nice straight construction line from one side to the next. Make sure you've got a decent gap between the bottom of the page and this line, please. I have written ground line towards the bottom right hand side. You don't need to do that, that's just to help you out today. Okay. Right, once we've got that out of the way, next thing we need to decide is, by looking at the exemplar orthographic, we need to decide which side should be our main view to begin with, which side should be the elevation. Now in this object it made more sense at the time to make the most complicated view the elevation, and that was looking at the object from its left hand side. Now if we think about our own designs and the exemplar that's on screen now, this isn't quite the same case on this product. Now, looking at the front of the birdhouse, we can see the entry hole, we can see where the perch is going to go, we can kind of see where the metal plate would be attached to the left-hand side of the object, but there's just not enough detail in there to justify making that the elevation view. Now, if we turn it round to this side here, yes, it's angled just now, but don't worry too much about that. We would sketch that pretty much straight on. Now, from this side, we can see the joints on the wood, mitre joint here, half flap joint here, half flap joint here. We can also still see the perch, and there's a couple of things hidden from us, possibly how the metal joints at the back is hidden, and obviously the entry hole is hidden. We can't see this from that side, but in saying that, because this side has the joints, it would make more sense to make that the main view, make that the elevation view. So that's perhaps where we're going to start with today. Right, now I'm going to draw this at half size, that's 1:1 scale. Don't worry too much about my measurements because your designs will all be different. So I'm going to look at the length of the product, and we'll call this the front, the elevation, and let's say roughly about 128, 130, something like that. So we'll plop it over to the side just now, and down here we're going to place the elevation here this time and project the end elevation over to the left instead of over to the right. Remember, you could do that both ways. So to start with, on the ground line, we're going to stick on our main height line. So that's at 90 degrees from about that point there, just a little bit further over than halfway. I'm going to stick in a construction line as the main height line and project that all the way up the page. Remember, we're sketching nice and lightly just now to begin with. Right, the birdhouse in this instance was, let's say, about 130, so we'll do 75 millimeters. And from there, I want to project that up the page, and with my straight edge, I'm just trying to get that as parallel to the other line as I possibly can. Because we're not using proper drawing board instruments, this is a sketch rather than a drawing. Okay, do the same thing for the height, because the object was square, and I'm going to take that line and project that across to that side. Okay, and that gives us the main outline of the wooden part of the object. Now, next thing, we have to show the thickness of the wood in construction lines. So the wood is 12 millimeters, so we'll be looking for a size of about 6. So I'm going to sketch in from both of those sides and put a little mark. I'm going to sketch down, put a little mark, up and put a little mark. So that's all at about 6 millimeters. We'll project this one across as a construction line, this one across as a construction line, this one up, and this one up. Okay, all nice and lightly. Now, the joint at the left-hand side is going to be a mitre, so that would be at 45 degrees, so from here to here. And the same at the bottom right-hand side. At the top right, that would be a half lap, so just a short line coming down here. And then at the bottom, the same there. I've just done those freehand. Short lines like that on the sketch can be done freehand. You don't always need to use the straight edge. Okay. Right, now that we've got that, we kind of should be also showing where the plastic would go. Now, if we bring the product back on screen, you can see that the plastic actually fits into the wood. This wood is 12 millimeters thick, so it actually goes to about that size there. There's a little rebate joint in there that allows the plastic to slot in and connect to it. Now that means that on some of the lines here, we can't line them in as visible because the plastic hides that. The plastic's going to come in about halfway, so what we can do is just another little construction line vertically halfway through each of those pieces of wood, and then at the top halfway through, and at the bottom halfway through. Okay, again, don't worry about being too precise. Now, in terms of lining in, we have to line in what is clearly visible to us, what we have direct line of sight to. So on the sketch, we would line in, I'll start with all of the horizontals first. So we would see the top edge here. Okay, now I'm doing this in pen. You are welcome to do it in pen if you feel confident enough. If not, just a little bit heavier with your pencil. So that's the top line of where the plastic would be. I'm going to jump down to the bottom. We wouldn't see this line here, that would be hidden behind the plastic, but we would see that line there. And then on the ground line, we would see that line there. On the right hand side, we obviously see the edge of the birdhouse carcass. Next one, okay, this little half lap would come down, and then obviously we sketch the rest of the line for the piece of plastic, and that would come down and connect to here. At the left hand side, we do the same thing, edge of the plastic to the edge of the plastic, but then the half lap would continue, like so. Edge of the wood here at the front, we would have, and then the mitres, we would see that much, and we would see that much. Okay. Right, now, next thing, we can't see the hidden detail lines, obviously, on the inside of the wood, but we still have to show the manufacturer that they're there. Now, we do have those as construction lines, so imagine that the piece of plastic was glass. Imagine we could see through that. Now, we would just about make out the rest of the mitre line here. We would then see the inside of the carcass, 12 millimeters thick, coming all the way around. So to show that in hidden detail, you would do this just as heavily as the outlines. But I'm going to do it in a green pen just to make it clear for you on screen. You wouldn't need to do that. Just a little bit heavier, but a hidden detail line is a short dash with an even shorter gap in between. Now, if you remember back to first year when I was teaching you this, or if you do Graph Com, technically a hidden detail line, the dash should be about 3 millimeters with about a 2 millimeter gap, but This isn't graphics, this is D&M. It doesn't need to be as accurate and perfect as that. Certainly not when you're doing a sketch. Okay. So I'm doing all of the horizontals just now. And the verticals. Okay, that would show the inside of the box. The half flap here would have a little dash there. Bottom right hand side, same sort of thing. Miter joint would afford a little dash in here and also in there too. Now that gives us the view for the carcass. Okay. Right, next thing we have to show is the hole, the entryway for the bird. Now, if I take a little measurement of that, I think we drilled that with a Forstner bit at 30 millimeters. 25 or 30, I think, is the most optimum size that you want to be going for. So, coming down on the carcass, I reckon that my hole would be about that sort of height down the way, so maybe say 20, maybe 40 millimeters, so half that size. And that would give us the top of the hole. We would then measure down 15, but remember I'm halving this. This is a half size drawing. So let's go for 7.5. And then another 7.5 added onto that is going to give us a construction line that would sit there. Okay. Now, again, because this is hidden from us, we would do a hidden detail line, top and bottom. And to show the manufacturer looking side on that this would be a circular hole rather than a square hole, this would need to have a center line. And center lines are short dash, long dash, short dash, long dash. And in a sketch, that's good enough. In this instance, I'm just going to line in that center line in red. And then we would do the same thing for the perch that would sit just underneath this. So just coming down to about that height there. And this time I'm going to project out, out, and then halfway construction line to show the center line. I'll finish that off. And this again is half the size of the physical model. Now, if your birdhouse is smaller than this one, if you've designed it to be relatively wee, then there's perhaps no need for you to scale the drawing down in any way. If you could fit all views at 1:1 scale onto the sheet of paper, then please do that instead. Makes life a little bit easier for you. So hidden detail lines in for the perch and a center line, long dash, short dash, through to show us where the perch would go in the object. Now, the only thing left to put onto this now is where the metal would come from. Now, I know that if you look at it that way around, that you can see the angle that's there. Looking at the back, we can also see where it's been screwed in, but I think we'll add these bits in later. What you're not going to see from this side is the fact that that metal is angled. It's just going to look relatively straight from that view. So I'll place this to the side for now. And we're going to sketch the metal in. Now the metal comes up, let's see. Yeah, that comes up about another 30 millimeters, so I will half that size and we'll go for 15. Same at the other side. Get my straight edge on again, and just make sure that it's still parallel to the ground line at the bottom. Construction line all the way across. And as we do see this, looking into that little gap, this would be a visible edge at the left and right, and also across the top, but we're not quite done there. Okay, now in this instance, if we look at it, the metal does have a thickness, and we do see that edge of metal from here. So that's not going to appear as a single line. It is only 1 millimeter thick, but we're just going to exaggerate that a little bit on the drawing and just double that line up at the top, just so that we understand that that does have a thickness at the top of that material. Okay. Right, to finish off, underneath the view, we're going to just sketch in a little construction line here, a little construction line here, and we'll put in the view titles. This would be elevation. And the only thing left on that view to do is to put the dimension lines in, but I think we'll do that once we have all of the other views in place. Okay, so the elevation view shows the birdhouse from what we are now calling the front. If we turn it to the side, we know that we would see the opening, the entranceway for the bird. We know that we'd see the perch, but we're looking at that straight on. We would see the thickness of the metal on the left and the angle of that at the top. Now, looking at the end elevation, we would show, obviously, the height of the object, and in this instance, the breadth. Remember, length would have been this way around. Okay, so we don't see the length in this instance, we only see the height and the breadth of the object. Now, just going to place that out of the way just now. Come down to our sheet of paper, and what we're going to do is we're going to leave a little gap, enough room to put the dimensions in, and I reckon just roughly about there would do. And then again, project up a construction line. In this instance, you don't need to go all the way, just let's go up to about that sort of height there. And we'll decide that that is, in fact, this corner, this edge of the object. Now, looking at the birdhouse, the exemplar, I am 100 millimeters from one side, or sorry, from the front to the back. I'm half in that size in this instance, so let's go for 5. And I'm going to project that up also. Now, these are breadths, remember. Now, the heights, we don't need to measure again. We can actually get those from the elevation. So this is relatively simple. So we'll start at the top, come down, and we see where the metal is. We're going to project the top of the metal across. We'll then do the bottom of the metal. Might be better to pull the ruler down in this instance. Okay, that shows the thickness. We come down to the top edge of the wooden part of the birdhouse. We can then come down. Well, in fact, let's just keep that on there just now. We'll possibly just put in a construction line for the thickness of the first piece, thickness of the second piece, and then I reckon just the centre of the hole and the centre of the perch, just to about there. Right, so we know that from looking at the end elevation of the physical model, that the top of the wooden carcass goes all the way across in that 100 size, but at the bottom we don't quite have a size for that yet. So take my ruler, put the ruler on here, and I've decided to make that 70, roughly about 74. So we'll half that size. Okay, there we go. And put a little line on here. Okay, bring this back on screen so you can understand. And we're trying to follow this angled line from the bottom to the top, so that would be from this part here all the way up to here. Remember, that's where the top of the box comes across, and the construction line straight down. Okay, and I'll keep the model on screen just now as well so that you kind of understand that. And we're going to line in the top of the wooden box, the front edge, the bottom, and the back. Okay. Now we need to show the thickness of the wood, and therefore this line here, which is projected across from there, would be hidden detail. So that shows us that wood is 12 millimeters thick. And we do the same thing again at the bottom. And try to visualize this. Because we are not looking at the object this way around now, we don't see the joint appearing as such. We would just see it as a 12 millimeter line, just slightly beneath. Okay. Right, now the center for the hole, the entryway for the bird, is, if I measure the model, I had decided to make it about 30. Yeah, let's see that. That would be roughly about there. And this is the center line, remember. Now, there's a couple of ways of doing this. First thing, you could measure out. Let me see. You could measure out 7.5 in each instance. Do the same above and below, and just sketch in. You could sketch in a little square, make sure that the centre's in place, a little square like so, and then split it in half horizontally. You've got the vertical split, and then diagonal to diagonal, diagonal to diagonal, gives you almost a little union flag. Now, to split this up into a circle, we give ourselves a little dot at the top, bottom, left, right. And on the diagonals, you want to go about 2/3 of the way out. And just try to connect those up. Now, you should be turning your page, turn your paper as you try to do this. I obviously am trying to keep this straight for you, so my circle might be a wee bit wonky. We're just trying to get all those little dots to connect up, and that gives us our little circle. You go back over that with pen if you want. The other way of doing it is just to get a little coin or a little counter, place that on. And remember, this is just a sketch, so if it's not accurate, that's absolutely fine. Or the other way, if you've got one at home, you could use a circle template if you want to get it a little bit neater. Okay, circle template. Just be careful if you're ever using pen. Yeah, we'll just pop it onto that. If you're ever using pen, the pen can allow the ink to run underneath the circle template, and sometimes that bleeds over your paper, so you might be better just to do this bit by hand. To show that that's circular again, you'd have your center lines in, short dash, long dash, and just have those projecting through the circle, tops and bottoms. Okay, now we can see where the construction line is projected from the elevation across the end elevation for the perch. Just sketch this one in. As long as it looks circular, that would be fine. And again, little center line, just to show that that's circular, and I'm relatively happy with that. Now, the metal is a wee bit different on this because we can see the angle. So just take a wee look at your development page that you've done, or if you made any cardboard models, take a wee look at that too before you sketch this on. In this instance, I have two pieces of metal that connect together. I don't want to overcomplicate this for you, so we'll just imagine that this is one piece of steel that's coming up and bending round. We do want to add in the joints, but we don't want to be talking about kind of overlapping 1mm lines. That just gets a wee bit too intricate. So in this instance, we know where the top corner is here, or rather should be, because if you follow the model, you can see that this is actually set into the side a little bit. And I reckon that's just about 10mm or so. So on the drawing, I'm going to come in by about 5 and decide that that's going to in actual fact be the top corner of the metal. I know that that's going to come down to the edge of the wood, so I can project the inside line. Sorry, 2 seconds, guys. I can project the inside line down. That gives us the inside line of the metal, but then I need to do a line that's offset by 1mm. That just starts here. Take that all the way down. And then bring your ruler up to the back edge of the box. Slide it out just a little bit to show the thickness of the metal. Project that down, and we've got the construction lines for the metal in there. Okay, I'll just line that in. Okay. And that would be good enough. Now we'll leave dimensions off for now, we'll cover those in a little bit. But again, underneath the view, I'm going to have a little couple of construction lines to help put the view title in. I try to keep these in line with the elevation there. Super light. And then in capital letters, centered across the view, end elevation. Okay. Right, next view is obviously going to be the plan. That's going to be projected above the elevation, not the end elevation, above the elevation. And in this instance, it would be elevation there, and plan would be looking at the object from above, like so. Now, there's something that can help us here, and that is bounce lines that we used back in S1. Now, instead of measuring all of the breadths out, remember, if you look at the top of the birdhouse, you're not going to see the height of it, but you do still see the length, you do still see the breadth. Now, we've got all of our lengths here. We've also got all of the breadths here, and all we need to do is kind of project them up and onto this plan. So I'm going to come to the top outermost corner on the elevation, and I'm going to project that out at 45 degrees. That's halfway in angle from that corner out to the left-hand side. Okay, I've done that a little bit darker just so you can understand it, but it would be just as light as a construction line. I'm going to call that bounce line. Again, you don't need to write the text down, but it can help. And I'm going to take all of my breadths and project those up for the wooden box. So that's that one to that one. I'll just connect them up vertically to the bounce line, and that gives us a little intersection. You wouldn't do this, I'm just circling it in red so that you understand. So that would give us a little intersection that happens here and here. We then take our ruler on, and we're going to keep that horizontal, and we're going to bounce that intersection across to the height line that comes off the object here. And we're going to bounce this one across to do the same thing to there. And what that gives us is a rectangle that represents the wooden part of the box just now. So again, we've taken the breadth of the box here, projected it up to a 45-degree bounce line, we've bounced that across horizontally, and that gives us exactly the same breadth, just looking down on the object instead of looking at it from the side. Okay. Right, now, looking down on the object, we notice that we see the metal before we actually see the wood. So we know that we've got the back edge of the metal here. If we project that up also and across, we do have that little material thickness of 1 millimeter coming in. So we bounce that up too, and that shows us the thickness of the metal. The metal at the front of the birdhouse sits a wee bit further in than the wood does. So we want to also take this one up and again project that one across. And just try to keep it parallel to the line that appeared before for the wood, and that would give us that edge there. Okay. So the metal part, as we look at it, just trying to fit all of this on screen for you. The metal part, as we look at it, we would see this back edge here. So that would be lined in like so. We don't see the thickness of the material because it's been bent. So this little line here, 1 millimeter in, that would be hidden from us. That thickness is underneath the metal, but we would still show it. Sorry, I meant to do that in green. That would show us the material thickness. Coming forwards, we know that we see this edge of the metal. That would be lined in. And we know that we see the two sides of the metal. So that would be from here to here. And on the opposite side would be from there to there. Now the wooden part, we do still see this little bit of the wooden part sticking out. So that would extend. That would extend, and that would extend. And then we need to just deal with the hidden detail of the object. So I'll put the birdhouse back out of the way just now. And we're going to think about what we would see in terms of material thickness. So looking down on the object from above, we would see the thickness of the material here in length, at the left and in right. So both of those would be projected up, like so, like so. And in addition to that, we would show those lines as hidden detail. But again, it doesn't go through the metal, so it would start roughly about here. Come forward, like so. Now as we get to the front of the wood, you need to be careful because remember the plastic sat just a wee bit flush with that. So plastic was halfway, that comes from here. So we project that up, plastic sitting in just about there, about 3 millimeters deep. 6 millimeters deep, sorry, and projected across. And then plastic here, up, projected across. So that would sit just in there like a little L shape. At the opposite side, this would be a mirror reflection of that. Okay. Short dashes. That's hidden detail all the way up. And then obviously the plastic itself, we know that it's flush to the front, so it would have a thickness. We've got that little line, and we're just going to put hidden detail in there too, to show where the plastic would go. We haven't quite done that on this view here, so what we could do is take the thickness of the plastic, project that back the way, from this point, back down to the end elevation, and we know that the plastic would slot in something like this. Okay. Right, circle for the hole, Same sort of scenario, so we take the centre line, project that up to the bounce line, so that was the centre line, up to the bounce line, we then project that across. That gives us the centre. We can take the edge up and the edge up, project both of those across, and that gives us the lines for the circle. So we'll stick the centre line in just now. Maybe just a wee bit wonky there, but I'll try straightening it up with the hidden detail lines and centre line. And that would emanate that. And obviously looking from above, the hole for the perch going in would be directly beneath the centre line of the entryway. So what I'm going to do is, if we just project up the length of the perch, just about here, and before I end up with hundreds of lines, I'm just going to decide that that's the thickness of the perch there. And then as it goes through the wood, would be hidden detail lines here. Okay. Now, the only other thing that I could add into that, let's just do the view title before we forget. So plan, again, leave a little gap, 2 construction lines, and then the view title. And the only other thing that we could add in there is perhaps the joining technique that we've used, screw cups and self-tapping wood screws here, and we've got little pop rivets there as well, but these things I've still got to show you in the workshop, so I think we'll leave those off for today. As long as we've got an understanding of the layout of the orthographic drawing and then the dimensions, then that would be good enough. Right, so we're going to add in, to begin with, just the 3 overall dimensions. And we'll do these in red, so they're nice and clear for you, and we'll position them in appropriate places. So the height of the birdhouse would come from the top of the roof, and we start off with a leader line which does not touch the object. It's a couple of millimeters off and comes out and extends to about there, all the way down to the bottom for height. Another leader line, leave a little gap, project across, and then the dimension line itself that touches the 2 leader lines with short, sharp, filled in arrowheads. Okay, and then our size, which was, let's see, okay, and I drew this at half scale, so I have 91,182. So you always don't scale down your sizes, you always write the sizes in as the product should be made. So in this instance it would be 182 millimeters. We write it, because it's vertical, just remind ourselves, as if we're looking at it from the right hand side. It's then above the line and centred, and you don't put in the mm. Okay, now we can do the same thing for, let's see, the same thing for breadth, and we'll do this on the plan. Oh, sorry, we'll do length to begin with. So from the right hand side, a little gap, then a leader line. Right hand side, let's include the perch. And in fact, we'll do the body to begin with, actually. And we'll bring the leader line up like so. Dimension line in. Short, sharp, filled in arrowheads. And then our size, which was 100 millimeters. And we'll do exactly the same thing for breadth. Now, breadth in this instance could be a wee bit messy. If we put breadth above the end elevation here, we are going to be able to see it and understand it, but there's so many construction lines going on here just now that we might actually be better sticking the breadth over here where we have more room. So from the back of the shape, a leader line that doesn't touch front of the shape, leader line and dimension line. Leave a little bit of room for the measurement this time, and short sharp filled in arrowheads. And from the right hand side, let's see, what did we make that? That was, let's see, so 96. Was it? Yeah, that'd be okay. 86 it was actually. Happy enough with that. The other thing that we could do is potentially the perch. We haven't added that size in there. Now, the leader line in this instance, we want to know the distance from here to here, not all the way through. We can use this leader line up here that connects to the back. We'll just extend this leader line up here. Again, it should be a couple of millimeters off of the object itself. We'll just add in another dimension line here, quite a short one. Short, sharp, filled in arrowheads, like so. And then our size, which was 30 millimeters, gives us that. So we have height, length, breadth. We could add in far more dimensions to that, but we might leave that for now. The only other one that I would definitely want to put in there is a dimension for the hole. That's a critical dimension because we need to use a particular size of tool for it. So the leader line would go straight through as if it was the diameter, all the way through and outside the object like so. Would then make that horizontal. Put in a short, sharp, filled in arrowhead, like so. And for diameter symbol, and then 30 millimeters, that would be cut with a 30 millimeter tool. Now, the only other thing that we could really add in there is maybe a detail box at the bottom right hand side. I think we'll do that in a wee second. Flash. Okay, so a detail box would look like this. You'd have the project, S3 Design Manufacture Birdhouse Drawing 1, with your name in there too. Scale, in this instance, 1:2. If you can fit a 1:1 on there, that's absolutely fine. And at the bottom right hand side, the third angle projection symbol. Now, all of that information, all of the theory to do with working drawings and orthographics is highlighted again in your textbook. I believe if you've got the first edition of the textbook, it's page 111. There's 4 other editions, so I'm not sure of those pages, I'm afraid. But you will find it at the end of the design section within the textbook. Give it a try. If you've got any questions or you get stuck, please send me a little message. I might even be able to squeeze in a 1-to-1 with you at some point next week. Okay? Right, thank you very much, third years. Good luck.